Hello, this is Mrs. Boots, and in this lesson we are going to explore the absolute value inequalities. Specifically, we're going to work the practice problems from this lesson. And so remember that all of the rules for the absolute values and all of the rules for the inequalities apply. So we have to keep up with both sets of rules. So for our absolute values, the absolute value has to be alone. And number one, the absolute value is alone, so we can create our positive case and our negative case. Remember, the positive case, you write it exactly how you see it. So we would have a -7 plus 5n greater than 12. The only change is that we remove the absolute value bars. For our negative case, the absolute value side stays the same, but we have to switch the inequality symbol and we have to change the sign of the 12 on the other side to be a negative. Okay, so we got to make sure we do both of those things for our negative cases. Switch the direction of the inequality symbol and change the signs of everything on the other side. Now we have two separate independent inequality problems. So we're going to add the 7 to both sides. So I get 5n is now greater than 19. Divide by 5. Yes, we get a fraction. No, it's not the end of the world. But that's okay. We can handle fractions, right? In my negative case, we're also going to add that 7 to the other side. And cool beans, we get a whole number. And -5 divided by 5 is -1. We are not done. You're kidding, right? Nope, not kidding. Inequalities always get graphed on a number line. The negative number should be on the left, positive number on the right. What kind of circles do these have? Yep, nice open circles. Neither of them have an equal to, so they're open circles. And now let's look at where we're going to shade. For the -1, we're shading to the left. And for the 9/5, we're shading to the right. Remember, the direction of the arrow gives us an indication. Last but not least, we do need to go ahead and write that in interval notation. So remember, we go from -infinity to our -1. -1 has a parenthesis. And we're going to unite because it's one side or the other. And then I have my 19/5 going all the way to positive infinity. Number 2. Okay, number 2, we notice that our absolute value is not by itself. So the first thing we got to do is get rid of that 3. Remember, you cannot distribute the 3 into the absolute value. We have to divide it out. So now it is greater than 7, because 21 divided by 3 is 7. So now we can come in and we can write our positive case and our negative case. So remember, the positive case is the exact same without the absolute value bars. Negative case, we got to do two things, right? We got to change the sign and we got to change the direction of the symbol. Alright, so now how do we solve for x? You got it. You're going to subtract the 1. So on the left, for my positive case, I now have x is greater than 6. And for my negative case, x is less than -8. No, we're not done. Yes, we're going to put it on a number line. Okay, on the left, we're going to have our -8. On the right, we have our 6. Do we have open dots? Yes, we do. Because both of them are just greater thans or less thans. There's no equal tos. And now let's see, which way are we going to shade for the -8? We're shade all the way to the left, and for the positive 6, all the way to the right. And now let's write that in interval notation. So we're going to go from -infinity to -8. Again, remember, you use parentheses with open circles. We'll go from 6 to positive infinity, Make sure you put the U in between to show that you're uniting the left side and the right side of the graph. Number 3. Number 3, our absolute values are by themselves, so we can go straight into our positive case and our negative case. So positive case, I have negative 6v greater than or equal to 30. For the negative case, we're going to have our negative 6v. Only this time, instead of greater than or equal to, we're going to do less than or equal to, and we're going to have a negative 30. So remember, change the direction and change the sign. So when I divide by negative 6, we know we're going to have a v, we know we're going to have a negative 5, but remember, that inequality symbol is going to switch. It's going to change direction. Okay, so we got a flip-flop thing going on here. So when we divide by negative, remember you have to change direction. Okay, so now we've got our negative 5 and our positive 5. We're going to put those on our number line. Remember, the negative 5 goes on the left, positive 5 goes on the right. And I see that both of these have a nice, big, beautiful dot. Okay, so let's figure out where we're going to shade. So for the positive 5, we're shading to the right. That's the direction of the arrow. And negative 5, we're shading to the left. So we ended up with an OR statement. Last but not least, we got to do our interval notation. So we're going from negative infinity to negative 5. The U shape from 5 to infinity. Did I do that right? No. Mrs. Boots is losing it. Those should be brackets. Why should they be brackets? Because we have closed dots. Very good. Okay, number 4. Number 4 is crazy simple. We got to get rid of that 4 on the outside, so I'm going to divide by negative 4. Divide by negative 4, both sides. So I have my absolute value of m is now, is that going to be a greater than or a less than? Yeah, you got it. We divided by negative, so we have to switch that inequality symbol. Now we can do our positive case and our negative case. Super easy. The positive case, there's not even anything to solve. We just write it down. The negative case, we only have to do one thing. Yep. We gotta switch the direction and change the sign. Super, super easy. Okay, let's put that on the number line. So remember, our negative goes first. Then our positive, they both have open circles. And now let's look and see where we shade. From the 1, we're shading to the right. That's the direction of the arrow. And from the negative 1, we're shading to the left. That's the direction of our arrow. Now let's put our interval notation in there. We're going from negative infinity to negative 1. This one has parentheses because we have open dots. Our U shape, and then 1 to positive infinity. Number 5. Number 5 looks super easy, but we got to get rid of that 5. So we're going to have to add that to both sides before we can split it up into our positive case and our negative case. Once we've done that, now we can split it up because that inequality is by itself. Remember, positive case, just write it down. No big fuss. We write it down and just remove the inequality symbol. Negative case, we switch direction, change the sign. Cool part is now it's already solved. We don't even have to do any fancy math. We just put it on the number line. Okay, negative 5 is going to be on the left, positive 5 is on the right. Do they have equal to's? Yes. So we get closed dots. My positive 5 is going all the way out to infinity, shading to the right, just like the arrow says. Negative 5 is going out to negative infinity, being shaded to the left. Now our interval notation, we're going from negative infinity to negative 5. Yes, we get that bracket, or U shape. Another bracket. Why do we have brackets? Yes, because we have closed dots. Number 6 looks like it's just as easy as number 5. We're just going to come in here and we got to get that absolute value by itself before we can split our cases. So I'm going to subtract 2 from each side. So I get x less than equals to 2. So 4 minus 2 is 2. Now we can do our positive case and our negative case. So our positive case, write it down. No big deal, just no inequality symbols. Negative case, what are we doing? Yep, change direction, change the sign. Gotta do both. Now we're ready for the number line. Put two little hash marks on there. Where's the negative 2 go? Yep, goes on the left, positive 2 goes on the right. Do they have open circles or closed dots? Yeah, big old fat closed dots. Now, from the positive 2, I'm shading from the left. The negative 2, I'm shading from the right. So this is a sandwich. We have a sandwich here. That's beautiful. So I'm going to do a bracket with a negative 2, and then a positive 2, and a bracket. We don't even get the infinities on this one. It's nice, short, sweet, and simple. Number 7. Number 7, our absolute value is not the same. Is not the same, but it's also not isolated. Look at that. So we got to get rid of that 14. We're going to subtract the 14. Move it over to the other side. Okay, so I'm going to have my absolute value of v plus 1. And now it's going to be less than negative 12. And for some folks out there, they're thinking, wait, Mrs. Boots, we cannot have it with a negative. Well, in inequality land, yes, we can have that negative. So we're going to have our positive case and our negative case. Positive case, remember we write it exactly how we see it. So we're going to have a v plus 1 less than negative 12. No big deal. Negative case, you still have that v plus 1, only now, remember, we have to switch our symbol, change direction, so it's going to be a greater than, and that 12 is going to be a positive. We change the sign of it. Now we can solve. So we got to subtract the 1 to get it to the other side. So for my positive case, I have v less than negative 13. And for my negative case, I'm going to have v greater than 11. Now we're ready to put it on a number line. Negative 13 comes first, 11 comes second. Do we have open or closed? Yep, we have open dots. From the negative 13, which way do we shade? To the left. And from the 11, we're going to shade to the right. Just shade in the direction the arrow is pointing. Last step, interval notation. We're going from negative infinity to negative 13. It is an open circle, so it gets parentheses, and we go from 11 to positive infinity. Number 8. Number 8, inequality is not by itself. So we're going to have to get rid of the 6. So I'm going to have the absolute value of negative 3x. We're going to add that 6 to the other side. And when we do that, we're going to end up with a positive 3. So it's greater than positive 3. Now we need to do our positive case and our negative case. Positive case, remember, just write it down. No absolute value symbols. Just write it down. Negative case, however, yep, you got it. We got to do both things. We got to change the direction. So I'm now going to have a less than and change the sign. Okay, so now I got to divide by negative 3. This is crazy. What do you have to do when you divide by negative? Yep, we got to change that inequality symbol back. So we got to switch the sign. This is why people get confused with their inequalities so much. It's because you're changing that sign back and forth, back and forth. But we've got it solved. We have x less than -1 and x greater than +1. We're going to put both of those on our beautiful number line. So I have my -1 and my +1. They both have open circles because neither one of them has an equal to. And which direction do we shade? From 1, we're going to shade in the right. And from -1, we shade to the left. I didn't put a lot of sandwiches on here, did I? Oh well, just giving you practice. Here we go. We're going to go from -infinity to -1. From 1 to +infinity. Please remember the U shape in between. Okay, number 9. Number 9, we got to do quite a bit of math to get it so our absolute value is by itself. First thing we're going to have to do is get rid of that 3. So I'm going to subtract 3 from both sides. Okay, that's going to be giving me a 2 with my absolute value, less than or equal to -4. Now we got to divide by 2. Get rid of that 2. Remember, you cannot distribute. Sounds like a bad record. Okay, so now we have our absolute value by itself. Now we can do our positive case and our negative case. Okay, positive case, we write it exactly the way it is. No big deal. Negative case, yep, you got it. We're going to have to change a couple things. Change the direction and change the sign. Alright, now let's go back and solve it. So we're going to subtract 9 from both sides. So I get n less than or equal to -11. And then over here for my negative case, I'm going to get n greater than or equal to -7. Let's put that on the number line and see what happens. So -11's on the left, -7's on the right. What kind of dots do they get? Yeah, they both have closed dots. That's awesome. My -11 is shading to the left. So that's the direction of the arrow. It's a less than. 7, the -7 shaded to the right because it is a greater than. Now we're going to do interval notation, -infinity to -11, bracket. Why bracket? Got that closed dot. Remember the U shape, and then we go -7 all the way to +infinity. Number 10. First thing we got to do is get the absolute value by itself. So I'm going to add 7 to both sides. Okay, so I'm going to end up with 10 absolute value of n plus 6. Greater than, that becomes 80. Now we got to divide by that 10. Remember, you cannot distribute. So I have absolute value of n plus 6 greater than, 8. And a nice, beautiful, simple little problem. Why didn't they just put that one down to begin with, right? Okay, so we got our positive case and our negative case. Okay, positive case, remember you just write it the way you see it with no absolute value bars. Negative case, what are we going to do? Yep, we got to change a couple of things. Change the direction of the inequality and change the sign. Now we have a super easy set to solve. We're going to subtract 6. So I get n greater than 2. Subtract 6 on the negative case. I get n less than -14. Now we're ready to put it on the number line. -14 goes on the left. 2 goes on the right. Do we have open circles or closed dots? Both are open because neither one has an equal to. Our 14 is shaded to the left. -14 goes to the left. +2 goes to the right. Always shade in the direction of the inequality symbol. Last step is interval notation. We're going to negative infinity up to 14. U-shape 2 to positive infinity. Good job. In this video, we're going to stop at number 12, and we'll work the other problems on a different video just to break things up. So number 11, first thing we got to get rid of is this -1. That -1 needs to be added to the other side. That way we can get our absolute value by itself, because right now it is not by itself. So we end up with 4, absolute value of 6r, greater than -96. Okay, it's not the end of the world. It's maybe a big number, but we like big numbers, especially if they're in our checking account. So we're going to divide by 4, not always fun. That means it's going to get smaller. We don't want the checking account to get smaller, but that's okay. -96 divided by 4 is 24. Alright, so now we are ready, because our absolute value is by itself. We can do our positive case and our negative case. Positive case, write it exactly how you see it. No surprises. Negative case, that's where we get our surprises. What's going on with the negative case? Yep. You got to change the sign. 24 is going to be positive, and change the direction. It's going to be a less than. Now we're ready to solve. We got to divide by that 6. So what is -24 divided by 6? -4. Positive 24 divided by 6 is positive 4. Now let's do our number line. Okay, -4 is on the left, positive 4 is on the right. Both of them get open circles because they both are just plain old greater than less thans. -4 shades to the right and positive 4 shades to the left. Cool. So we have a sandwich there. So I've got a parenthesis with a -4 and another parenthesis with my positive 4. Number 12, last problem for this video. First thing we got to do is add that 5, get it to the other side. Okay, so I'm going to have 3 absolute value -6a minus 6 less than equal to 45. Okay, now we can divide by that 3. Remember, we do not distribute. That gives us an absolute value of -6a minus 6 less than equal to 15. 45 divided by 3 is 15. Isn't that cool? Okay, absolute value is by itself. Now we can do our positive case and our negative case. Positive case, we write it exactly how we see it. Negative case, what are we going to do? Yep, you got it. Same old, change direction and change the sign. Okay, now we actually got to go through and solve it. So we're going to add 6 to both sides. So I got -6a less than equal to 21. I'm going to have to divide by -6. That's going to switch that inequality symbol back in the opposite direction. Okay, so now I'm going to have a greater than equal to over here. And 21 divided by 6, I know I can reduce that to 7 over 2, because 21 and 6 are both divisible by 3. Okay, let's do the same thing on the other side. We're going to add that 6, add that 6. So I get -6a greater than equal to, that becomes -9. Right? When we divide by 6, we're going to end up with 3 over 2. It's going to end up being positive because a negative divided by a negative is a positive. And yes, we do have to flip the inequality symbol. Now let's go through and do our number line. Cute little number line there. 3 over 2 is smaller than 7 over 2. They both have equals, so they both get a beautiful big closed dot. 7 over 2 is shaded to the right. 3 over 2 is shaded to the left. So for our interval notation, we're going to go from negative infinity, 3 over 2 with a bracket, U-shape bracket, 7 over 2 to positive infinity. Okay, it's too bad I can't hear you guys through the screen. I just realized I made a mistake. That 7 over 2 should be negative because I divide by negative 6. So let me redo that number line over here. So my 7 over 2 is negative. That means it's going to be on the left. 3 over 2 is on the right. And then we have our dots. And then we're shading. If we look, it's going to end up being in the middle. Okay, which means we're having our negative 7 over 2 to 3 over 2. It is a sandwich. It does not go out to infinities. It's a sandwich. And this concludes our lesson, or the practice, numbers 1 through 12.